Okay, Paul, if you want to take it up and
well,
give you
certainly. I didn't prepare any particular presentation because mostly I'm interested in hearing the kind of questions that people have and talking with our colleagues about different ideas. My specialty, of course, is operations, and that is taking program direction to say go off and build and operate a space station, for instance, and then taking the equipment which is built and helping consult with how to build it so that it's more useful, and then actually operating a space station or a spacecraft. As an engineer, I look at that as a challenge, because in order for us to have a long-term future in space, which I believe the human race does, we need to learn how to survive and have our equipment survive long enough to take us to the planets, to spend 500 days going to Mars and back. And the ISS is a tremendous laboratory for us to do that. Everyone here who is an engineering student has worked in a laboratory and discovered that when you build a piece of experimental equipment and you start operating it, that you have problems. A motor burns up, you spring a leak, something doesn't work exactly the way you thought it did, so you have to re-engineer it, redesign it, make new parts, try new parts, and it's an iterative process to come up with something which is really reliable. And it's no different in space, except for the fact that space is a very different environment with the thermal extremes that we have and the microgravity. Things that we take for granted here on the ground, lubrication of a motor shaft, for instance, or the way heat flows, become a very big challenge, and it's an entirely different set of parameters that you have to design to. And you can sit and think about it all you want, but you really need to get up there and try things. So what we're doing on the space station is developing technologies to understand how to make our systems run long enough so that we can go where we want to go and live off this planet. I think that the ultimate goal for the foreseeable future is Mars. And in order to get to Mars, it's a lot safer to develop a lot of the technologies by being on a closer planetoid, which would be the moon. And there are all sorts of things that we're going to discover that people don't always think about. For instance, if you're going in and out of your spacecraft on a daily basis exploring the surface of a planet or the moon, every time you come back in, you're going to bring in dust. And that dust is going to be on your boots, and that dust is going to be on things. And if you're going to do that, you have to figure out how to clean that and how to deal with that dust getting into the equipment. That's what happened in Apollo, in the lunar modules. They got quite dirty. You can come up with a different alternative where you never bring your exterior equipment into the module, and you can design around that as well. So these are the lessons we need to learn, as well as simply how to do operations on a daily basis and not wear your crew out, wear out your people on the ground. How do you come to agreements when you're working with international partners? Because I do believe that the exploration of space is going to be something which is not national, it's going to be global. It requires people from all over the globe to come together. It's a very expensive proposition, expensive in terms of commitment of resources. And so we learn on a daily basis on the International Space Station. It's a laboratory for figuring out how to work together, how to allocate those resources, how to give everybody a turn, so to speak, and how to support the people that are doing the work. So that's part of the things that I would like to be able to talk about is how you make those operations work and how we learn what we need to learn to carry us much farther into the solar system.